Notification. All right. Okay, I have too many monitors here. Wait a minute. So, Paul, I'm not going to be able to watch the chat because my eyes will be way over here. So throw something at me. Okay, well, it's 3 o'clock, so let's get to it. My name is John McBee. Thanks for joining me. This is a really cool event, and I'm impressed with how the virtual aspect is working so nicely. I want to talk about futures and promises and a little bit about hamburgers too. I wasn't sure exactly who could be in the audience, and so I tried to make this more approachable. I'll also start by saying I am by no means an expert in futures and promises and their implementations in other languages, but I've done some reading and talked to some people outside of our ecosystem. And I want to walk through, kind of with a fun example of what they are, and then show you some code. So spend the end of the application, end of the presentation in some LabVIEW code, showing you an example, doing a little bit of a code review, and hopefully lots of questions. I don't know how that's going to work out in this format, but we'll do our best. All right, compose systems, working on the tagline. This is supposed to be tongue-in-cheek if you're not familiar with me. But in general, we are a LabVIEW solutions provider. We work a lot with high-tech startups in New England, and a lot of what we do with LabVIEW is we build alpha and beta systems for people who are developing products, which is a cool application, allows us to work on really interesting problems. Be happy to talk more about that with people offline if they're interested. And I want to start by just giving an overview of solution space. And I say this because we've developed some open source tools that are all out there, and we use them on most of our projects. And what I'm going to talk about now is in addition to that tool chain that I'm looking at. And just in general, this is kind of what our applications tend to look like. So we have a presentation layer, which is the views, and they're usually nested in some hierarchy. Then our business layer, which handles interactions with the views and causing the system to do something. And that do something is done in the resource layer. In between the presentation layer and the business layer is a bus. And so we have a package that we use called MVA. And MVA has viewables that you can use to write your front-end application. Then we communicate through the message bus, through the view model, down to the business layer with MVA models. MVA models handle user interaction, and we then have to do something useful with it. And so an example that almost all of our applications have is the MVA model side in the business layer will drive a process model. And that process model is a link between MVA world, which is event-driven, and sequencing world, which is another package we have, the test executive, which is a really powerful dynamic sequencer that's scriptable and all sorts of interesting things you can do with it. And then if you look down in the resource layer, the green boxes there are what we call services. And I'm going to mention services a bit today. I'm not going to go into much detail on them because they're an extra layer of complexity that I don't have time to dive into. But the test executive needs to interact with services. And how does it do that? Well, we end up with test steps that execute. They have to make service or request services to do something. And one thing I've been playing with recently, and I'm using it on a project right now, is the software I'm going to show you, where I'm using tasks, which a task is basically just a wrapper around futures and promises. And that allows me to do sequencing in a different way that decouples the sequencer from the services. And that's proven to be a hard problem to solve well, in my experience. Over on the far left-hand side in the orange box, we've got cross-cutting aspects that are kind of used all throughout the different layers, like the event logger. You'll see the event logger in the demo code. It gets used at the resource layer of the different resources I'm going to show you. It gets used at the task implementation as well. My demo is very simple because it kind of needs to be, so you don't get any presentation or business layer here. And another one is configuration. Now, the cool part is that all those dark gray boxes that I just made show up. Those are open source packages that you can go to gpm.io and pull down and start playing with yourself as well. So we write these tools, we use these tools every day on all of our projects, and we'd like it if other people tried them too, because, you know, grow the community, and we also benefit if people make our tools better for us. So if you're interested, reach out to one of us. We'd be happy to talk to you about it. And today I'm going to focus on the area in the red box. Like I mentioned, primarily we're going to zero in on tasks. And I will talk about services a little bit. If we have time at the end, I'll show you some code with services, but it's just a lot to wrap your mind around. Before we dive in too much further, there is a blog post on the LabVIEWcraft blog site, which I run, by Owen Search, who used to be a partner at Compose Systems, and he's still a good friend. And a lot of the content from this presentation was rooted in his blog post from 2016, and then just conversations that I've had with Owen since then. As I've kind of learned that I might need this as part of my solution for decoupling the parts of my application. So what's our problem space look like? Well, we're gonna introduce the ideas of futures and promises and all the other things through a conversation about ordering hamburgers. And I think it will hopefully be more approachable than talking about JavaScript or C# or Scala or some other language that implements them. I think this hopefully works. So let's really talk about what happens when you order a hamburger. First thing you do, you go to a restaurant that has a hamburger on its menu. So already there's some underlying expectations here between the interaction of our things. One thing being you or me, the other being a restaurant. There's an expectation that I know how to go to a restaurant, I know how to interact with the restaurant, and I know it has a hamburger on its menu. So we're already loading these terms up pretty good. You place your order with an employee at the front counter. That's an important detail, that you're really just talking to that one person to get the order taken. You don't go back and talk to the cooks. The employee presses some buttons on a register. In exchange for payment, the employee gives you an order number. And this is where it starts to get nuts. Now we're doing things in parallel all of a sudden. It's getting asynchronous. Somewhere in the restaurant, someone or someones are cooking our food, we think. You know, they're doing a lot of things. They're probably cooking other people's food too. But then I can go off and do whatever I want to do. I can go get a soda, iced tea, napkins, ketchup, vinegar, whatever I think I want to do to fill my time. And this takes some time on both sides, right? It takes a bit of time for the restaurant to do what they told me they would do and cook my food. That means that I have probably more time than I want to have. So maybe I'm sitting there checking my phone or watching the kids. But eventually, they finish cooking the order, they put it together, and they call my order number. And then I go and get the food at the pickup counter, and I drive home where I can, you know, do what I do. So let's unpack these one by one. So first statement, we go to a restaurant that has a hamburger on its menu. So we're going to try to think about these things through the lens of writing software, which is what we do. So you being the you in the sentence are a consumer. The restaurant is a producer. The consumer has access to the producer's API in this case, right? The restaurant has exposed a public method saying you can order a hamburger. And I know about it because it's on the menu, and I can call into that. The consumer expects that API to expose a request for the hamburger, right? So we have this expectation between the two. And we'll see it's kind of nuanced as we get further down the list. But hold on, wait a second. I used words that we're all familiar with, producer and consumer. Those are loaded for us, right? So it's a design pattern that we've all seen before. It looks like this. These are asynchronous loops, so it fits the what we're talking about here. They share a queue or some other transport mechanism, but you know, this is what we all start out with is the queue. There's some expectation that information flows from the producer to the consumer. And in general, this can be kind of hard to scale up, but it makes me want to maybe change my words. So you are an asynchronous loop. And again, I'm being fuzzy here because in the real world, I would say you are a session. And that's my word for this is an asynchronous thing that does some work is a session. But I'm going to avoid that word a little bit because I'm not going to tell you anything about sessions, even though you might want me to. Can't make me. The restaurant is an asynchronous loop. I have access, same idea. And my expectation is that the API the restaurant has will expose a request for a hamburger, right? So it'll basically tell me how to request a hamburger from it. Second sentence, you place your order with an employee at the front counter. So like I mentioned before, it's important to recognize that I'm interfacing with a small portion of the restaurant, right? I'm not going back and looking at the people stocking the freezers or washing the potatoes. I'm just talking to this one person, and it's their job to communicate to everybody else that I don't even need to know about what they need to do to satisfy the agreement that we make. The asynchronous you has to have a way to both know about and call into the asynchronous restaurant. I mentioned that before. I have to know there is a restaurant. I have to know how to interface to the restaurant's API. So we'll look at this in code in a few minutes. The act of calling into the restaurant's API is called making a request. So you're going to start to see bold letters. Those are of vocabulary that we're going to build up. So request is meaningful in this future promise task API. And the small idea of one asynchronous bit of your application being able to interact with another asynchronous bit can be a tremendous source of coupling, both syntactic and semantic. And I mentioned this before, that a lot of times when we're writing these big applications that do really crazy things, the part of the code that bothers me the most is when my sequenced bits have to interact with my service bits. And how do I do that in a way that reduces coupling so that they don't become a point of inflexibility in my software? And that's a hard problem, and I tried to solve it a few different ways, and Paul and I have talked a lot about it, and that's kind of what's driven us in this direction. So I threw out some buzzwords, so I'll just define them for you real quickly. Syntactic coupling, when one part of your code depends on another part of your code. And a nasty example is, say you have class A and it defines a type definition, and then class B uses that type definition. If class B has it in its private class data, that can be super fun. Semantic coupling, when one part of your code has an expectation on behavior of another part of your code. So now we're talking about behaviors and expectations. And so syntactic is literally the code that we're writing depending on each other, knowing about each other, and semantic is expectations that are difficult to code into the software, but they still have that. And as an example of semantic coupling, if I order a hamburger at a restaurant and they give me one of those toy plastic hamburgers back, they may have fulfilled their promise. They gave me a hamburger. It might even look like the one I ordered, but the expectation was it was one I could eat, not a plastic one. So the next line, the employee presses some buttons on a register. At this point, I don't need to know what the employee is doing, and that's a good thing. It's by design. I don't want to know. It should be entirely abstracted away from me, what's going on there. All I need to know is how to make the request. How it gets processed should be abstracted, right? So what I do care about is that what the employee is doing is creating a promise that the restaurant will fulfill based on a request that I made. So I send a request into the restaurant. Somewhere behind the curtain, a promise gets created, and I know that they're going to fulfill that promise at some point. One detail that doesn't map well is the idea of payment. This is funny. I didn't actually get to catch the presenter before me, but I know he was talking about blockchain a little bit, and I was just kind of half joking when I put this in there. But it'd be interesting to talk about using blockchain with smart contracts and micropayments to kind of lubricate the communication between these asynchronous bits, right? Because what happens if, well, I don't want to spoil it. I'll get there in a few minutes. The part we care about here is that the employee gives you an order number, right? So that's what I get back out of this transaction. And the asynchronous restaurant gives the asynchronous you a future. So I'm going to equate that order number with a future. And that can look like a couple different things. It can be one of those little black things with the red lights and the buzzes, or maybe they give you like a little table tent with a number on it. There's lots of different types of future that get presented in this interaction. We'll just say that they give us an order number. Then since I mentioned promise and future for the first time, I'm going to try to define them here. A lot of times, I'm not sure if everybody here is familiar with the concept that we're talking about, but this is where people have a tough time delineating, is what is a promise versus what is a future. So a promise, when asynchronous component A makes a request on asynchronous component B, B creates a promise to fulfill that request. And the promise is not exposed to asynchronous component A. So like I said, it's kind of behind the curtain. The fact that a promise gets created, I don't get visibility into that, but it needs to exist. And on the future side, when the promise is created, the promise creates the future, and the future gets passed back out to me as the request maker. And I'll show you how I implemented that in the code, but it's important to note that the request maker gets the future, doesn't know about the promise. The request fulfiller needs to leverage the promise to be able to fill the request in a nice decoupled way that gets the future back out to the requester. All right, I was getting distracted by comments. Now it gets crazy. So up until now, we've had a synchronous interaction between the you and the restaurant, and now we get asynchronous. So not that crazy. So at this point in time, both sides of this equation are able to do what they need to do. So the restaurant's busy getting my food ready, getting other people's food ready. I'm busy getting ready to receive my food, so maybe getting some napkins, getting my drink, ketchup, vinegar, whatever you need to do, so that when the food is ready for you, you're ready for it. And truth be told, it doesn't really matter what I'm doing. And it doesn't matter a lot to me what the restaurant's doing, as long as they're doing it, right? There could become a point of contention with regard to time. Time is always a point of contention. We'll talk about that in a second. But in general, we're just completely asynchronous at this point, and all that either of us really care about is that a promise has been made, that a future will be fulfilled. Yeah, which is what I just said. The restaurant's working on fulfilling the promise, and I'm waiting to redeem my future. So eventually the food is ready, right? The kitchen finishes, and they call my order number. So that means that it's time for the kitchen to fulfill the promise and for me to go and cash in my future. But there is a bit of nuance here that I haven't really talked in depth about. But how does the restaurant notify you or me that their promise has been fulfilled so that you can redeem the future? And there's a couple ways to do it. And I'm going to talk about two scenarios. One is continuations and one is called awaits. So you can think of a continuation as you telling the restaurant what to do when your order is ready. So when I place my order, along with my request, I also pass in just a verbal, hey, could you shout my order number, please, once it's ready, so I know and I can come find it. Or can you send me an email? Like something, so I'm going to trigger some event, or I want some event to be triggered once the future or the promise has been fulfilled. In the hamburger scenario, this could be me requesting, like I said, to scream the order number. Or I could ask them to bring the order to my table if they give me one of those little tents. But the important bit is that once the promise has been fulfilled, the restaurant will do something that I want them to do. Await is a little bit different. So await is part of the API for future, and you'll see that in a few minutes here. It is a method. I think it's the only public method that you can call on future. So it's the only thing that me as an asynchronous bit can do with my future is call await. It's a blocking call, and it does have a timeout input. The important thing about await, and what I find interesting about it, is that the ability to do that avoids an inversion of control problem. Because if you think about using callbacks or even continuations, what that's saying is when the food's ready, I want you to interrupt me, whatever I'm doing. You interrupt me so I know it's time to get the food. Awaits invert that to where the food can be ready, and I'm not going to know about it until I call await on the future. And if it's ready, then it's ready. I can go get it. Now, this is something I like to talk about when we get to the code, particularly people who thought about this, what their thoughts are. In my implementation, and I think this is valid, you get to call await one time. And that await is either going to return the value, the hamburger, in the amount of time I specify with my timeout, or it's not. And timeout is a perfectly acceptable way to fulfill a future, right? That's okay with me that it times out. I need to handle it because it didn't do what I thought it would do, but at least I know it didn't do what I thought it would do. You can also get error codes out of the await. And so if the restaurant caught on fire and when they tell me the order's ready, I go to get it and I get, say, a receipt with an error code, that's perfectly fine too. That's how they fulfilled their promise, is by saying, sorry, the restaurant caught on fire, so you're not going to get your food. But at least I get to find out. And the important part is that I find out when I want to find out. So the problem with time, what if both you and the restaurant are very busy? All right, so say you place an order with the restaurant thinking it'd take 15 minutes to fulfill, and I'm scheduled to deliver a baby 30 minutes from now. I don't have a lot of wiggle room there. It's got to be ready in 15 minutes. So I have some time to eat and then some time to get to the baby delivery place. Now, when I call await and I specify timeout, the future will return a valid timeout error, which is perfectly fine, which will then go and cancel the promise. So like I said, you get to call await one time. And when you call it, and I'll show you the implementation, if it times out, the future await goes and tells the promise, sorry, we don't need you anymore. I'm curious what people think about that decision. And then just as an aside, why do we pay for our food when we make the request instead of when the future is fulfilled? Maybe micropayments and smart contracts make that better. So now just rehash the vocabulary because I threw some buzzwords out there, and these are going to be important because they kind of define the code that we're going to talk about. So a session, I mentioned that I'm not going to talk about it, but I'll tell you about it anyways, is a wrapper around an asynchronous component. So in the hamburger scenario, both you and restaurant could be sessions. We have a specific implementation for sessions. I don't know that sessions as an idea exists outside of our brains. Like I just don't know. So I'm not claiming that this is vocabulary everybody should know. But that's how I'm using the word. A request, so a session API is made up of requests, and it's up to the session to expose what it can do publicly to the rest of the world. So in the hamburger scenario, the restaurant session has a place order request in its API. In the demo code, that's the only request that I actually wrote, so it's the only one I'm going to show you. I could have other ones, obviously. Note, my demo code doesn't have real sessions. What I will point out as we look at the demo code is why sessions are a good layer to have in between the code that does things and the task layer, because you can abstract away some stuff. A task is ephemeral and it orchestrates the promises and the futures. So a session executes a request by passing it into a task, right? So you kind of compose a task with a session and a few other bits that we'll see in a second. And then the task ends up basically launching the promise. And the task is really ephemeral. It only needs to live while this promise exists. The promise, so the task creates the promise and passes out a future. So when the task creates the promise creates the future. The promise then gets the future back to the task passes the future out so that it can be used by the caller or the requester. And the promise oversees fulfilling the future, and that's fulfilling it with expected data or fulfilling it with error, whatever you got to pass in. Some implementations in other languages allow you to specify on error, on complete. I didn't do that in my implementation. We can talk about it when we get there if you have thoughts on it. I really wish that we could turn everybody's mics on because I don't have any idea what people are doing. It drives me crazy. A future, an object that will at some point contain information, data, or hamburgers. It's very simple. Like it's literally a class with, I think, 2 methods. A continuation. So when, like I said, the session makes a request, it can pass in a continuation. And this allows the requester to say, once the promise is fulfilled, trigger this so I can go and do something. There's an interesting idea called continuation stacking that I'm not going to talk any more about. So I can just mention that it exists, where you can kind of queue up continuations and trigger them to just go. It's kind of a functional approach to programming, and I think you could do this with my implementation. I just haven't had a chance to play with it yet, and I don't want to tell you that I have and I haven't. And then await. Await is a public method of future that a session can call when it wants to retrieve the information. And this call can timeout. Any questions before we go into the land of code? Nothing? Doing good. So I'm not associated with Five Guys. In fact, I've only eaten there once since the pandemic. I think that's a testament to my willpower. So let's get into the code. I hate that picture, by the way. It shows up. Can you guys see that? Yes, you can. All right, so is that too small? Paul, is that too small?
Yes, can you bring it a little bit more in focus? I mean, it's we can kind of see it, but it's not great.
Let me try it real quick. How's that? That's fine. It's just huge, but we'll deal with it.
Yeah, that's much better.
Okay, so I'll start with just saying, like I said before, I didn't really know who my audience was going to be, and so I didn't want to throw too many things at people at once. And so this example I tried to make it simple. I tried to make it similar to the producer consumer that we're all familiar with, whether we've used it in a long time or not. And in doing so, I ended up creating, fake classes because it's just ingrained in my brain at this point. But you'll notice that over here under example, I've got a restaurant. This could have been a session, and it looks like a class even though it's not. And that restaurant has private class data here, which is just a type-defined cluster, so not really private class data. There's no protection on this wire, obviously, because it's just a cluster. But I basically have a restaurant down here with some methods and some data, and I have a U up here with some methods and some data. And like I said, I tried to model after producer consumer. Encapsulated on this wire is a queue. So my queue is my transport to go from restaurant to U. When I create my restaurant, what I'm doing is I'm creating my queue, and I'm caching that queue here. And I do that because I don't want to just have a naked queue out there in the world that anybody can put or try to put something onto. I want to really control how that gets used. And so putting it inside of my type-defined cluster allows me to provide a public, I can't enforce public because it's not a class, but an API where the intention is you can call this public method on this wire, U being the asynchronous U. I've also got the event log, so I'm not going to talk about it, but it's here. You can see this is how we create an event log. This is reuse code. If I poke back at the project, you'll notice we have an externals folder. I don't know if you saw the presentation an hour ago by Ethan and Steve, but they talked about a workflow for package management that we're working on where we use externals in Git. But effectively, these are two reuse components that I've sucked in to this idea of a task, and I depend on those open source packages. And one of them that you're seeing is the event log. And so I can get the event log into my restaurant like this. And you'll notice that U has a very similar constructor where I'm putting an event log, a separate one, because I wanted to be able to show the two in parallel. Here, there's no transport for U here, because the idea is that U is going to make a request to the restaurant, and the restaurant's going to fulfill it, and I don't have to have a transport going back the other way, unless I want to define one as a continuation, which I do here. So first, let me just run this, and then we'll talk about the code, and then we'll look in detail at the implementation, and whatever you guys want to talk about, we can do. So you can barely see it. So if I restart the application, I can place an order. So let's say that I want a hamburger. When I place this order, I'm going to be calling into the only public method of the restaurant. And I'm going to be saying, here's my order. I'm also going to define a continuation, which I'll show you without the continuation in a second. But inside of this dude here, you'll see that I get a future back out, and I'm just caching it in my private class data here, my private data. And so when I make that call into the restaurant API method, I just define order as a string. I define continuation because I want one. I get a future out, I cache it, then I log to the event log that an order was placed. And you'll see that pop up. I told you I was just going to run it, and here I am looking at source code. So if I run it, this is a list of what the restaurant's doing. This is a list of what I'm doing. So when I place my order, you notice that there's a bit of synchronous stuff happening right off the bat, but we got past that part. I ordered, the restaurant received the order, created a promise, it started the promise, and now it's trying to execute the order of make the hamburger. So it's cooking food. Now I can go and I can get a drink. I made that take too long. I can go and I can get napkins. And once they're done packaging, they're going to fire that continuation, and that's going to force me to get the food, right? Because I'm not calling fulfill future myself here. So once the promise is fulfilled, we see that in the log. The promise kills itself and goes away. Down here, the continuation fired, which caused me to call await, which I'll show you. And that got me my future out, which is a hamburger. So it came back out the other side. If we go down here, I'll just walk through this a little bit. So let's look up here. What happens when I call into the public API? I'm calling place order, and it's just a simple string invariant, and my order is a string going in. Continuation gets passed in. This here is a method. Well, I don't have classes, it's just a VI of the request. And I'll show you the request in a second, because you have to create your own request implementation. It's very simple. It's just a couple of VIs, but you do have to build one. I told you I'd point out where sessions are a useful layer of abstraction, and this is one of the areas. With that session sitting in between, you don't have to know to create a request. That's done for you. And the sessions are a reusable component too. And so you just get to go and plug and chug when sessions are in between. But like I said, sessions don't exist today for us. They do exist today, just not for us. Inside here, this is execute request. And so underneath the hood, what we're doing is we're taking the queue transport and we are enqueuing a handle request, and it's got all the stuff we need to know about to make the magic happen. So we create a notification that's going to hold the future. We pass in the continuation that we want if we want it. See the request here getting wrapped up in a secret way. And this will go communicate down to the restaurant loop via this transport to handle this. This will run, and our notification comes back out the other side, and we have our future to operate on. If we go down here, you'll see handle request. And again, on the other side, this is task code here. So this is code you don't have to write, but you do have to understand, unless there's a session in between the doers and the task, which we don't have here. So we have to write it ourselves. But what we're doing here is we're creating a task, and then we're executing a task. And this is happening inside of the restaurant. And so the restaurant session needs to know how to do this so that we can create a promise. Now, again, for this example, all that I had to do was pipe things into these methods and know that I have to send the return notifier. That's some knowledge I don't want everybody to have, which is why I like the idea of a session, because it abstracts that away. You don't have to know to do that. If we take a peek what's going on under the hood inside of the task, Pretty simple. So under the hood, we are just packing it up, packing all the stuff into the task. Not doing anything crazy here. Again, logger. So logger exists inside of the task API, which is reuse code. It's just baked in there. So it's one of those cross-cutting concerns we saw in orange. It's kind of present in all levels of the application. And then on execute, this is where we spin up our promise. So the promise is an actor. The fact that it's an actor doesn't matter to anybody but me, because you don't have to know how to use it because it's baked into the API. But I made it an actor out of convenience. And so I launched my promise actor, and then I call start promise, which we're going to go look at. Notice that I'm passing the request back out. And again, this is something that I prefer to have abstracted away. But for this demo, since we don't have sessions, the request has to be cached by the restaurant so that it can go and fulfill the promise later. So hopefully the idea of why sessions are nice to have kind of makes sense. I know I'm kind of being hand wavy about it, but sessions introduce a lot of other complexity I don't want to talk about right now. So we saw the promise getting spun up. Let's go take a look. So we've seen the restaurant API. Let's actually go down here. So this is the task package, future, promise, continuation, a future transport, a request, task, and task types. These are actually just data types that I needed for the task. So we take a look at promise. We called start promise in that message that we saw. This is what start promise looks like. Again, this is all the reusable component, so you don't have to write any of this yourself, you just get it. This is what start promise does. It takes in the request, it caches the continuation, it passes the future out, it logs start promise. So again, you see that the promise has access to the logger as well. This is just a wrapper around the event logger, and just logging some data for us so we can see what the promise is up to. This is an abstract method of the request class that is must override. So if you want to create your own type of request, you must override the send request method. And you can see that for the demo, I created this override here. And what the request object allows you to do is basically define your own transport for how you want requests to move around. And so in this case, the transport is the queue transport because it's a simple producer consumer. Inside the session implementation, it's a wrapper around actor framework messaging because under the hood, sessions are by reference wrappers around actors that expose actor messages as an API. It's a cool idea. But the important part is you can extend it to fit whatever your need is. And so it doesn't try to force you to use an implementation.
John, you had a question on futures. Are the futures reusable, or are they on a per use basis?
Do you mean the actual object that gets created, or do you mean on the edit time side? I'm guessing you don't know, Paul. Okay, do you create a new future for each request? Yeah, you create a new future for each request, and you cannot reuse them. So this is an interesting point to talk about. Right now, the way it works is futures are single shot. You get one out when you make a request, and you get to call await on it one time, and then it's dead to the world. I actually, decided to violate that rule at the session level because there are times when, and I'm still kind of playing with this, but where it could be beneficial to launch something like, say, a motion request where you're moving some motors, and you want to get feedback periodically of where the motors are. And it would be nice to be able to call that future and get the current value on the future. So when I wrote the futures, at first I made them notifiers, thinking, oh, they're single shot. Once you call it and you read it out, the notifier dies and you're done. Then I went back and I changed them to be dynamic events under the hood so that I could queue up things for the future should I want to later. So I've got an implementation. I don't know if I'm happy about it or not because I don't think it's in line with the idea that I was trying to implement, but I think there was a need for it. There's this idea in JavaScript called observers, and observers exist because of this problem where futures and promises are single shot, which means you can't cancel them and you can't call into them more than once. And so they have this other idea called observers. I kind of smashed the idea of observer into the idea of future for my implementation. I don't know if I should feel bad about it or not, but I'd be curious to see how you feel about it. Did that answer the question? Well, we'll see. If it didn't, feel free to ask again. Yep, so that's what happens here. This is always just going to blindly call send, and send's going to do what you defined it to do. So back up inside of the example, my request here, I overrode send, and you'll notice that it's what we just looked at. And that's all that I had to do to define what the request type is. And at this point, the promise is up and running. I'll show you another thing here with promises. So I made promise an actor, and I overrode actor core even though there's no UI components. And I know that typically that's maybe a code smell, that if you find yourself overriding actor core without a UI, why are you doing it? The reason that I decided to do it is because, like I said, I wanted to make use of dynamic events here to drive how futures and promises interact with each other. And so let me see if I can show you two things here. I don't have a ton of space. If we look inside of await.
Johnny, do you have one other question about sharing of futures? Can you share a future with another session?
Yeah. You can share it with anything. You could even package a future up into another request if you wanted to. Yeah, that's definitely the idea. I'm just thinking right now to make sure I'm not lying to you. I'm pretty sure I'm not lying to you. Yeah, I'm not lying to you. Futures are entirely self-contained. Once you call await on that future, it doesn't matter where that future originated from. And I can guarantee that the promise I created the future is going to stay in memory until the future is closed out by an await. So yeah, you can totally make a request, get a future, put that future into another request, and daisy chain. And I think that is a thing people do in other languages. All right, Alan says it's not a code smell. That is good enough for me. If Alan says it, then I believe it. Talking. Yes, okay, so I have this promise actor. I'm making use of dynamic events. Now inside of my await, this is the future method await. And I wrapped up a transport. I wanted to abstract away how the future worked from the future API. And so I wrapped up the transport. And you'll see that under the transport hood, that this is what await really is doing. And I'm just using dynamic events here to drive it. And so when the promise gets created, it creates this dynamic registration. And it gets cached in the future transport. And then you go and you do whatever you want with that future. Pass it to other sessions, put in your own state data, doesn't matter. But when you're ready, you're going to go and you're going to call this event structure. And it's either going to time out or this dynamic event is going to be captured. If the event is captured, then I send a message back to the promise using a different dynamic event, basically saying await complete, so the promise knows. If it times out, then I send a different message back saying await timed out after this much time. And you can see that on the front panel. Where's my front panel? Here, promise completed, await complete. So this is it making its way back up to the promise, and we're logging that with the event log. Oh, and look, I made a note to myself, custom error codes. So there aren't, I don't have unit tests around this yet, which is why I haven't published it. I think somebody asked about how do you get your hands on this code. I just haven't made it public yet because I don't have all the things I want to have around it. But that said, if people want to play with it, I'm happy to make it public and just mark it as beta so that you can use it at your own risk. All right, where'd my project go? So what else can we do? The future can also check to see if it's a valid future, which isn't being used anywhere. And that's just another future transport method. It's going to tell me if it's valid or not. Data's fine. Yep. Let's talk about continuations. So you'll notice here that I do create my continuation. Just for fun, let me stop this. And I'm going to delete that wire. So at this point, I am not actually going to pass a continuation in. So when I run this code, let's say we want a cheeseburger. It's going to do the same stuff. We're now back in asynchronous land. The kitchen's doing whatever it wants to do. I'm doing whatever I feel like I should be doing. I guess I could have made this take less time. Seemed like a good idea at the time. All right, so now the promise has been fulfilled, but I don't have my order yet, right? And I don't know that the promise was fulfilled because I didn't ask it to tell me. Now when I'm ready, I can go and I can call await, and it's ready, so it's going to give me a cheeseburger. If we go modify that again a little bit, what I want to do, fulfill future. So right now I've got a 1 second timeout. Let's run this. So I'll place my order for the cheeseburger. Now, if I try to fulfill it right now, it's going to wait a second and then it's going to time out. And notice when it times out, it kills the promise. What I haven't done, because I don't have a session in between the service layer and the task layer, is I haven't told my restaurant to stop doing what it's doing. So you'll notice that even though the promise has been closed out, the restaurant is still trying to make my food, even though at this point I'm out the door. So it's another nice abstraction you can build into this, the session layer, is have it handle these things for you. All right, but how do we create a continuation? Let's look at that. Let's stop this. Oh, yeah, it's never going to finish because I'm not there to take the food. So like I showed you before, when I place my order, if I want to pass this in, I can. This is pretty simple. Again, I tried to make as few assumptions as possible on what people would want their continuations to look like. So there's, again, one method you have to override. This is a must override. And I called it fire. I should have called it send continuation so that it matched the future, but I didn't. So in this case, I've wrapped up a dynamic event. And I've basically just said, okay, promise, whenever the promise is fulfilled, fire this off blindly. And in this case, it's going to send that dynamic event to me, and I can go get my food. So building continuations is pretty simple. I had to make a configure method here. And this is all that it's doing, right? So just getting the transport into the private class data of the continuation object there. What haven't I showed you? So, I mean, that's kind of the meat and the potatoes.
John, there's another
Yeah,
question.
that's good. Were you going to ask the one, why not return the food with a continuation message? Yeah, so I thought about that. I even talked to Paul about that. Should we include the future as part of the continuation message? And we decided not to. I don't have a good reason for why we decided not to. It's just we decided not to. I'd be curious to get other people's thoughts on whether or not the future should be part of the continuation, because we could easily do that. We could stick it in there. I think the reason we didn't do that is because then the writer of the continuation would have to know that to write the code to put the future into the transport that they want to use. That might be the only reason. Oh, why use it at all? Yeah, I mean, it is kind of like a callback, right? So you could just do that. The reason is that I want to force people to call await so that the promise dies. So yeah, I could totally change the way it works to where the continuation will stick the hamburger in the message, and then kill itself, have the promise kill itself. Yeah, it could totally be written that way. Yeah, so the reason like I said, I was just trying to learn about futures and promises through the lens of other languages. And this is the API that other languages present, the ability to call a continuation or to call await. The thing I like about await is that you retain control of your own execution, right? Nobody's going to interrupt you. You get to decide when to call await on the future. I like that aspect of it. And I built continuations in to try to, I mean, I was learning, it was part of the reason, is I'm learning what other languages have and how it works. And I wanted parity there so I could think about it in my world of LabVIEW here. Once this gets used in real projects, which I'm starting to use it now, I'll probably be able to make some decisions on which ways make the most sense to me. But I'm just not there yet. So I'd love feedback. If people have thought about this or have similar implementation, how they find themselves using these similar kinds of levers. Cool. So, I mean, that's the meat and the potatoes of this. Did you guys have any questions? Did you want to see anything? I think I showed you most of the stuff here. I will make all of this available, including the example for you to download. It'll be on our Bitbucket. You can go and pull it and use it, play with it, decide if you like it or hate it. If you like it, you can help me make it better. Yeah. I'm just looking through. All right, well, that's all I've got for you. I don't want to go into sessions right now because I don't have enough time to make it meaningful. So I guess if there aren't any questions. Yeah, I don't disagree. And like I said, I was aiming for parity, and my guess is that once I use this, and if anybody else uses it, it'll be easy to form an opinion on what we want to do. Await seems to fit. Continuations exist, so I wanted to play with them too. Not listening for a future, right? The continuation, if you want to inject one, you can, I mean, that's more or less what it does, right? When you inject a continuation, you're basically saying once the future is fulfilled, I want you to do this. And that's going to be something you're registered for in some way, whether it's putting a message on an actor queue or it's firing a dynamic event. It's up to you what the transport is. It doesn't matter. But yeah, you're not actively, you don't have to listen unless you want to. Yeah, if you prefer to just call await, then you can just cache the future and then call await whenever you feel like it. That's one thing Paul and I were kind of talking about a few days ago was right now there is no way to kill a promise aside from calling await on the promise. And that means that the promise is at the mercy of the requester to do something with the request. So is that good or is that bad? You know, like there's no way for the promise to kill itself unless the application comes down, then the promise will kill itself. Oh, so a great question about test executive. So I meant to mention this, but I don't have an example to show you. I think that there's a really powerful idea with regard to sequencing tasks in here, where right now, the way that it functions is we build these test steps, and the test steps can just be classes or they can be models, where models is very meaningful. It means that they have access to the message bus. But I like the idea of maybe trying to sequence through tasks better, where then you kind of build up all of your tasks and you build up a sequence of those tasks and you just kind of run it. It seems like a really functional idea, functional being like a functional programming type of idea. I said a bit saying that I'm waiting for something and then expect to receive a complete message in the future. Oh, yeah, like a callback, Casey. Yeah, it's more or less what a continuation is doing. It is saying, send me this when you're done, and I will get it at some point. Yeah, so it is similar to callback messages where the difference is the inversion of control, right? Where the awaits allow you to decide when you go and try to collect the future instead of passing that off to somebody else. And so depending on how your code's written, if you didn't write it all, you could be depending on third-party code or code that Paul wrote, never trustworthy, to only fire that callback once or to fire it at all. And that can interfere with your execution. And so in that context, it can be safer for you to own the responsibility of calling a wait on the future when you expect the data to be ready. And so that's that inversion of control that I mentioned before. Yep, yeah, I agree. Receiving a complete message just indicates that the service I asked for is done. Man, I wish we could talk. This is ridiculous. All right. Well, I'm about out of time anyways. I appreciate you guys suffering through my presentation. Hopefully it was useful or at least interesting. And I can put the demo code up in Bitbucket for you guys to take a look at. And like I said, it's open source MIT license. If you're interested, let's collaborate and make it more useful. I would love that. So otherwise, see everybody later.